Alright, this video we're going to be solving with expressions in the numerator, and what that looks like is something like this, where you have 5 plus x, an expression in the numerator, and then something in the denominator. So the easiest way to deal with this, it's very simple, and once you see it you'll probably catch on really quickly, is if you have something in your denominator and you want to cancel it, multiply both sides of your equation by the denominator. So if I have that 6 in my expression with that 6 in the denominator here, I'm just going to multiply both sides of my equation by 6. And what happens is we have 6 times -1 equals -6. And that right here, what happens is you will get, now this is like converting, or the conversion factors when we did ratios and proportions and dimensional analysis. You can cancel this 6 in the numerator and this 6 in the denominator, and then it's gone. They cancel out, and so what you're left with is just the 5 plus x, which is a really simple equation to solve. You just add the opposite of positive 5, which is -5, to both sides of your equation. This cancels. 5 plus -5 is 0. And -6 plus -5 is -11. So you get x equals -11. So we didn't have to do step 3 because the coefficient of x, if it's just x, its coefficient is 1. It's solved. But we do need to do step 4 and check the solution. So let's check. If x is -11 and we plug in -1 equals 5 plus -11 and divide by 6, does that equal -1? Well, to simplify this expression, I have to add what's in the numerator first, 5 plus -11. So when I do that, I get -6. And then I've just got a division problem. Well, -6 divided by -6, is that -1? The answer is yes. So -11 is, in fact, the correct solution for this problem. All right, let's try another one. V plus 9, all divided by 3, equals 8. So again, I've got this 3 in the denominator and the v plus 9 expression in the numerator. So first thing I'm going to do is just multiply, both sides of my equation by 3, whatever's in the denominator. Now, again, that will cancel the 3 in the denominator, and it leaves the expression v plus 9. And then 8 times 3 is 24. Now, this becomes a one-step equation. From here, I just want to add the opposite of 9, which is -9, to both sides of my equation. That cancels. 9 plus -9 is 0. V equals, all right, 24 minus 9 is 15. And, of course, we do want to check to make sure that 15 is, in fact, the correct solution. So I'm going to plug in 15 plus 9 in the original equation. And does that equal 8? Well, 15 plus 9 is 24. And 24 over 3, that's just a division problem. 24 divided by 3, is that 8? The answer is yes. So that is your correct solution. All right, let's look at another one. So number 8. We have n plus 5, and that expression divided by -16 equals -1. All right, well, now I've got a -16 in my denominator. I want to get rid of it. The trickiest thing here is make sure, if your denominator is negative, you multiply by that negative number. Multiply by it on both sides. This cancels, and I'm left with n plus 5. And that equals, well, -1 times -16 is +16. And from here, it's a one-step equation, so add the opposite of 5, which is -5, and equals 16 minus 5 is 11. Last thing we got to do, check our solution. If I plug in 11 in place of n, does that expression equal -1? Okay, so I'm going to add what's in the numerator first. 11 plus 5 is 16, and 16 divided by -16. Is that -1? Well, yeah, it is. So that tells me n equals 11 is the correct solution. All right, let's look at some more slightly difficult problems. So now my expression in the numerator is a little bit more difficult. Not much, but we've got 3x minus 11. And we've got this 5 in the denominator. So regardless of what's in the numerator, we're still going to multiply both sides by whatever number's in the denominator. That cancels what's in the denominator. We're left with 3x minus 11, so that numerator, and 2 times 5 is 10. Now, the only thing that makes this more difficult is instead of having a one-step equation like we did in the previous examples, now we have a two-step equation. So I'm going to take the constant negative 11, add its opposite to both sides. I get 3x, this cancels. 10 plus 11 is 21. And then divide by 3 on both sides, we get x equals 7. And of course, the last thing we want to do, check that solution. If I plug in 3 times 7 minus 11, and that quantity divided by 5, does that equal 2? So I'm going to do what's in the numerator first. So I got to go over here and show this on the side. 3 times 7 is 21. And 21 minus 11 divided by 5, does that equal 2? So still got to finish the numerator. Simplifying that, 21 minus 11, well, that's 10. And 10 divided by 5, does that equal 2? Well, yeah, it does. So 2 equals 2, which tells me that this is the correct solution for the value of x. All right, last example. 5x minus 16, divide that by 6, and the solution is negative 6. So, just like the previous one, yeah, we've got this slightly more difficult expression in the numerator, but I'm still just going to multiply both sides of my equation by the 6 in the denominator. This cancels. I get 5x minus 16. Negative 6 times 6 is negative 36. Okay. I'm going to add the opposite of negative 16 to both sides. That cancels here. I'm left with 5x equals negative 36 plus 16, negative 20. And then I'm going to divide by the coefficient of x, which is 5, on both sides. And we get x equals negative 4. Very last thing. Let's check. So if I plug in negative 4 into my original equation, do I get negative 6? So let's simplify this numerator first. I have to multiply 5 times negative 4, so that gives me negative 20 minus 16 in the numerator. Divide that by negative 6, or sorry, positive 6. Does it equal negative 6? I'm going to finish off checking right here. Negative 20 minus 16, both negative, so we're going to combine those. We get negative 36 in the numerator. Divide that by 6. Does it equal negative 6? And it does. So that tells me x equals negative 4 is the correct solution.